Hi everyone and welcome back. Today I'm joined by Colin Gagich, co-founder at Inference Labs. In this demo, we're going to look at how computer vision moves beyond simple object detection. Most people are familiar with bounding box. A model detects an object and draws a box around it. But in production environments like aviation, manufacturing, healthcare, and infrastructure, teams often need more precision. For example, many use cases will need to understand shapes, boundaries, posture, movement, and relationship between people, equipment, and physical spaces. We'll cover three things today. First, the segmentation. Second, the compliance and governance pressure around AI system, including the EU AI Act. And third, proof of inference and why it matters when teams need to prove what a model actually did. So let's start with the platform. Colin, can you start by explaining the difference between detection, segmentation in simple terms and show how that looks inside the sertn?
For sure. And thanks, Elena, for the question. I love answering this one. And you kind of alluded to it a little bit in the opening there, but essentially a bounding box is really one of the finest forms of detection that we have in terms of the overall how big is the box that encapsulates the object that you're trying to detect. Segmentation takes this a step further and answers the question of, is this pixel in an image part of the thing you were looking for? You can then, with that segmentation, do a lot of different things. And there's a really obvious example that everyone probably uses almost every single day, and that's actually for the blurring of your background. If you're using Zoom or other software, basically there's this segmentation model that's running. It's very coarse, and it's saying, is that a person or is it the background? And if it is the person, it's not applying the blurring effect, and it's blurring out your backgrounds. It's a technology that we are familiar with. It does feel like magic. I have it on right now, as do most people who are probably Zooming from an office, their home office. So yes, we see this all the time. And then there's some other things where the bounding box would really get us into trouble, actually, with detection. So it would lead to something else being triggered when it's not quite, in the region that we think it is. There might be other things related to multiple objects stacked on top of each other, where differentiating the space between them actually matters, and which one is object A, which one is object B. These are all kinds of use cases that segmentation really lets us solve.
Now, that makes sense.
And let's dive into it. Let's take a look using a great example on sertn. So we've got this open here, and one common use case is for segmentation is actually pulling out data within an object, or the state of the object matters. So I've got this is an analog gauge at a wellhead in a petro use case. And this, I think, shows it perfectly, right? You have the overall gauge, the dial that's showing you the reading in PSI between 0 and 6,000. And then further to that, you have this needle. What is the actual measurement that this instrument is getting? So knowing the difference between the pixels within this bounding box, or specifically this needle, as you can see, you got this beautiful polygon outline around here. It's a very important distinction. If you had just this bounding box alone, it doesn't really tell you what you need to know about the gauge in any form. So I hope it's a really good example to showcase that.
That's an excellent example. I can see you have some more screenshots for us.
Yes, there's a whole bunch of different ones we can take a look at. And again, it's just a data set of different pressures in different times of day. You can clearly see that it's able to very easily pick up, even in these kind of unusual cases, the entire outline of this needle, this indicator. And then what you can do with this is you can combine it with our other functionality, our workflows, to then read this gauge, to further collect information from this. And for example, You might want to know when this needle has crossed over into the red zone. When this system is going above pressure, maybe you want a low pressure warning to go out. So we'll do a demo on how to set that up. So we'll do high pressure warning. Started. Now we're going to use Iris to help us out with this. Versus automatically looking at the workflow that I have open, my projects that I've recently been working on and trained a model for.
For users who are not familiar with Iris, can you elaborate what it is?
Iris is our in-house AI assistant that knows sertn better than I do, better than anybody at our team, and is very easily able to put together workflows, help you train new projects, help you with hard computer vision problems, and everything from starting from scratch to further refining a complex workflow that you've put together. So it's made a suggestion here, and it has said that it's going to set up this trigger when there's a specific detection zone, the needle class, which is exactly what we were looking for. And we're going to say, yeah, go ahead, let's run that. And it has set that up. And what we need to do next is just go in and highlight the exact high pressure zone ourselves. So we will do that. Pick this as our reference frame. And we are going to use our polygon draw tool to select the high pressure zone, which is everywhere above 4,500 PSI in this case. I'm going to draw it a little bit wider than we need. And that done. And we can see that Iris has set up a workflow for us here. And we'll just take a look at it. So after an inference has finished, it's going to check if an object is within a specific region, and it's going to rate limit that so it doesn't send us 100,000 notifications. We only want one within a certain time period. It's then going to send me an email for that. Okay, so back to our wellhead example, we should probably take a look at what a proof of inference looks like and how you can take that and show somebody else exactly what's happened here. So I've got a one of these images here. We'll just pick this one. We've trained our model to pick up the gauge itself as well as the needle. We're now going to run inference on this model. I'm going to keep the confidence level relatively low, although we saw it's a relatively performant model. We could probably bring this up a bit more. The confidence here is we're about 95%. You can see we've picked up both the gauge and the needle. And what sertn lets you do, and this is in the realm of meeting the compliance required for the EU AI Act, particularly Article 12, it actually generates this certificate for us. The proof of inference for this exact run that we had done. I'll just open this up here. It downloads on your machine and is reusable. You can see the image that's gone through, the exact bounding boxes that were detected down to the pixel level. And then, of course, you can verify that the certificate itself is authentic by either scanning the QR code, or if somebody were to have this, you send this to a customer, a regulator, an auditor, they can actually verify the authenticity of this certificate themselves by uploading it back into Sertn. And I will show you what that looks like now. You can just drag and drop it, and it will show that it's been verified and provide a little bit more, some more metadata about this exact inference, some of the input, output, model IDs, and other pieces showing the entire set of verification checks for this inference that happened. So really end to end, it shows that this image was run through this model, and here's the result.
That's great to see that we can have a QR code attached to the output. And it allows people and companies to verify everything at the palm of their hand.
What I can say is that as of the start of August 26, the EU AI Act is coming to enforcement. And what we're hearing is a lot of companies are just not prepared for this incoming change. Article 12 requires that anyone operating AI making decisions in a high stakes or high cost of failure environment is keeping and retaining adequate evidence of why AI was making decisions and what happened for this exact inference. And the reality is that logs are just not enough. They can be modified, they can be tampered with, they can be just straight deleted and pretend like an event never happened. And a lot of companies know that this is opening the doors to future liability if they don't have some system in place. Sertn is one of the only options for computer vision to meet these requirements, and it's really a market first and thinking about how we actually solve these problems for enterprise rolling out computer vision solutions. So we're really excited to bring this to market.
Can you show us what segmentation looks like in aviation?
So here's another great example of where segmentation really makes a difference. Road, which is meant for service vehicles only. This is in a relatively smaller airport. They don't have a lot of infrastructure to help with these cases. It's ultimately up to the operators of the vehicles, whether it's safe to go or not. But you can see that if this aircraft is a little bit taking a little bit of a wider turn than they should be, or a little bit narrow, sometimes these can happen because again, this is a very small airport. They can end up with the tips of the wing extending quite far over onto this road. And for little vehicles like this, it's not so much of an issue. But we've all seen at an airport, there's catering trucks, there's other types of vehicles that have a lot more height than a little service vehicle like this. And you end up with these close calls where the aircraft have gotten a little bit closer to a vehicle than they should have, or there's this potential for these types of things. So what you can do in these cases is you can just record that these close calls have happened, categorize the time of day, figure out who was involved in it, and really automate this process. As a lot of the times it may not, if no one's there to witness it, it might not ever be recorded. You might not actually know about these instances where it could have happened, right? So it's a great tool. Segmentation lets you say, this is the aircraft wing, right? You can see it's really done a great job at highlighting where that is relative. You can see that to this bounding box, it's actually quite a bit different, right? A vehicle that's off here on the side, you really don't care about it, right? It's not really relevant. Or if you had just had traditional bounding boxes, you might be getting all these false alerts all the time. So this really, I think, helps show why segmentation makes a difference. And further to that, this is another example. It's never that simple, right? Because you do have sometimes leading vehicles that are helping aircraft navigate around. There's a whole bunch of different reasons why you would do this. A simple set of rules of just, if vehicle on this road, send alert it's not enough, right? You do need to really spend a lot of time going through the different possible scenarios where vehicles could be or are not supposed to be in relation to aircraft or other objects on the airfield there, and really put a lot of thought into what exceptions it is that you're looking for, because you will see scenarios like this happen all the time.
Okay, excellent. So let's talk about training data. How much typically training data do we need to use case like this?
It really depends on the object that you are trying to track and detect within frame. And a lot of these models are pre-trained on everyday objects like aircraft, like vehicles, like analog gauges. But it's definitely, we've seen cases where you are trying to detect something very specific under specific conditions. You do need a good variety of data to really get started. What we find is that we often do projects in multiple phases, where the first phase, a system is running in the background, it's collecting data. There's some detection that's running and acting as this initial exploratory phase where we're looking for these exceptions, looking for where the system performs well, where it has room for improvement, and collecting more data over time. But generally, with just a single 10-second video clip, you can make quite a bit of progress and get a jump start on most computer vision projects. We've seen how easy these modern tools make it to develop your own data sets, to find existing data sets, to even annotate them yourself or have the AI help you with that. There's a lot of options these days to really hit the ground running.
I have one more question, if you don't mind. How difficult would it be to adapt this model to a different airport or aircraft type?
It's surprisingly easy. And in fact, what we've found is that these models are capable of detecting aircraft and types of aircraft that it has never seen before, whether it's obscure cargo aircraft that aren't a 737 or traditional Airbus or Boeing manufactured aircraft. It generally will be able to generalize those aircraft and pick them up with surprising results. And this happens all the time. Sometimes you get aircraft at an airport that you don't expect. Maybe there's a military aircraft that needs to land for whatever reason. It's something that you may not have had in your training set. But yes, you'll definitely be surprised at how well these models generalize.
Today we looked at how segmentation moves computer vision beyond simple object detection. As this system becomes more capable and enter real-world environments, accountability becomes just as important as performance. That is where sertn and proof of inference comes in, giving teams a way to preserve and verify which model ran and which output processed and what output it produced. Thank you for watching, and we'll continue exploring more production computer vision workflows in future demos.
Thanks for the time, and see you again.